Hey everyone, Dr. JC here again. Today we're going to talk more about genetics, and we're going to talk about a gene today that is often overlooked, and a lot of people don't really think that it's that significant and impactful because it has to do with our saliva and what's in our saliva. But we're going to learn today that this gene actually has a significant impact on our health and how we break down food, and also what foods we should probably be focusing on eating depending on this gene, and also it can influence what decisions we make based on on this genetic makeup. So for us particularly, so what the gene is called, this gene today we're going to talk about is called the AMY1 gene, and this gene dictates the amount of the enzyme amylase that's in our saliva, and this enzyme is responsible for breaking down carbohydrates. So when we eat that slice of bread, that pastry, that rice, that sweet potato, so those carbohydrates, what happens is this gene produces an enzyme in the saliva that is secreted when we begin to chew our food. So that saliva will contain different levels of this enzyme depending on our genetics, and this will begin to break down the starches at different levels of optimum ability depending once again on our genetics. So there are two different versions of this gene. There is first a T version, T like Thomas, and there is also an A version, or A like Apple. So individuals that have, say for example, two T versions will have more copies of the gene, and the more copies, the higher amount of saliva amylase there will be in the saliva. The individual who has two T versions can have up to like 18 copies of this gene, to give you an idea, compared to someone with two A versions who may have only 4 or 6 copies. There are also individuals that can have one T and one A. They are more like middle of the road. But let's compare the individuals with the 2T versions and the 2A versions. So a person with 18 copies of the gene, once again having the 2T versions, they will produce 3 times more the amount of this amylase enzyme per milliliter of saliva than a person that has the 6 copies of this gene. So why is this significant? Well, the person with 18 copies, when he or she begins to consume that carbohydrate rich meal, that sweet potato, the rice, the quinoa, that person with 18 copies, as they begin to consume that starchy carbohydrate, they literally, well, first of all, begin to taste and perceive a sweeter palate. So they'll have a sweeter profile sooner than the person who's chewing away at the same meal but has less copies of the gene. So the individual with the 2T versions and more copies will actually be absorbing that glucose, those carbs, from that meal earlier in the meal, in the eating process, than the person with the 2As. And so this will prevent that lump sum amount of glucose to affect their system. So in the case of the folks who have the lower salivary amylase, they're not breaking this down, the starches in their mouth, especially if they're not chewing their food very well. That's also a huge component. So therefore, all those starches and the carbohydrates will have to be broken down in the gut and through the pancreas amylase. So those 2A versions of this gene will have much more of a glucose spike, and this is where the problem lies. So the people that have the 2A versions of this gene, if they consume meals that are high in carbohydrates, they're at a significant risk of obesity. In fact, they are 8 times more at risk of obesity when consuming a diet high in carbohydrates compared to those who genetically just have more salivary amylase. So not many of us think what's in our saliva as being that important, that significant, that impactful. But this is just one of the many examples of how our genetics can influence our health, and also what food choices that we make. Also, how valuable it can be to understand our genes and get our DNA tested. So I hope this information was helpful, and I look forward to sharing more of this genetic information with you. So I will see you on the next video.